Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is subtraction in linked list, and it is a hard level problem. So this problem is not difficult as such, but it rather requires some very fundamental simple concepts, so simple that we often tend to ignore them, and that is why this problem might seem a little bit difficult. And other than that particular concept, this problem is purely implementation based, so you'll also have to be very careful about your implementation, otherwise you will get wrong answers, right? So it basically says that we have been given two linked lists that represent two large positive numbers, and we have to find the difference between those numbers. So difference is basically subtracting those two numbers, and we have to subtract the smaller number from the larger one, right? So basically means we have been given two values, both of them are positive integers. We have to find the difference between them, and that difference has to be absolute difference. That means the final result should always be positive. So as you can clearly see that the first value is 100 here and the second value is 12. The answer is 88. Even if it was the other way around, the first value was 12 and the second value was 100, then the answer would have been still the same, because we have to subtract the smaller value from the greater value, right? I hope this part is clear to you. Now coming on to the constraints, you can clearly see that the value of n is very huge, and if the value is up to 10 raised to power, this is 4 I guess, yeah, so 10 raised to power 4, that basically means each number will be like in terms of 10 raised to power and that many number of digits. So basically the value of each number can be up to 10 raised to power 10 raised to power 4. So this is very huge, and you cannot possibly convert it. So one idea or one way of solving this problem could have been, take this particular linked list, convert them into integers and then solve the problem. But since the numbers are very huge, you cannot possibly convert them into any integer format. The only thing you can do is make operations on this linked list only. Now the question is, how do we actually do it? So I'll try to divide this problem into two different parts. The first part will be that the first number, let's say first number is greater than equals to the second number, and then the second case is first number is less than the second number, right? Both of these cases have to be treated a little bit differently. We'll see in a while why, right? So let's say we want to find out the value of f minus s. So if the first number is greater than equals to the second number, then the answer will be greater than 0, right? That is good enough. Now what happens when f is less than s? That means the first number is less than the second number. In this particular case, the answer will be negative, but we want the answer to be positive only. So one possible way, what we normally do in subtraction is, we interchange the numbers and then subtract second minus first. In this case, the answer becomes positive and the overall calculations are a little bit simpler, right? So this is a very valid approach that we generally do, but the problem with this approach is the current constraints of the problem. You see, with the current constraints, we cannot possibly calculate these values of second and first. So we have no way of comparing these two and finding out which one of them is the bigger one, right? So we don't have any way to arrange these numbers in such a way so that the first number is always greater than or equals to the second number, right? What we generally do, whenever we are stuck in this particular case, we find out which number is bigger and we just convert it into the first case, right? This is what we generally do in subtraction. So if I try to give you an example, let's take this particular example only, 112, right? So 100 minus 12 is simple because we can find it out to be 88. But whenever we deal this kind of problem, 12 minus 100, then what we do is we interchange the numbers, calculate the answer and put a minus sign in front. This is what we generally do. But here we cannot find out which number is greater, so we cannot possibly figure out which of these cases is in the current scenario, right? So how do we actually solve this problem? To solve this problem, we need to go a little bit deeper into basic subtraction concepts, right? So let's first do 100 minus 12. What we do here is, we just do normal carrying or borrowing operations, right? So we have 0 here and 2 here. So 0 minus 2 will be negative. It is less than 0. That is not possible. So what we do, we take one carry from here and then it becomes 10. So 10 minus 2 is 8. So it was already 0. It has been, 1 has been taken from it by the right member and 1 is being subtracted from here as well, right? So what it will do is, it will take a carry from here, it becomes 0, this one becomes 0. When it took the carry, it was 10, 1 was contributed to the right member, 1 was taken by this particular value, so 10 minus 2 is 8. Now here it is 0, so we have 0 here. This is how we generally compute 88 in borrowing method. Now what happens if the numbers are switched? So 0, 1 and 2 and 1, 0, 0. These are the two numbers that I have now. So what I'm going to do is 2 minus 0 is 2, 1 minus 0 is 1 and 0 minus 1 is minus 1. So here it is minus 1. What we were generally doing when our value was going negative was borrowing one value from the left, right? But you can clearly see there are no members to the left of this particular number. So what we can do is we have no option but writing minus 1. So we have now minus 1, 1 and 2. But this doesn't make any sense at all, right? Why is this minus 112? But if you see it carefully, that it is not actually minus 112. It is looking like minus 112, but it is not actually that particular value. Why? Let us understand that. So these values were never negative, right? Or even if they were, we were trying to make them positive by borrowing one value from the left, as in this particular case. So these two values are positive and this minus sign is only for this particular digit. So let me just explain what I said. So the minus sign that you see here only belongs to this specific digit, not to these particular digits, right? So this minus sign is only for the leftmost digit and not for other digits. So what I can try to do is I can try to expand this particular value. So it can be written as 2 plus 1 into 10 plus minus 1 into 100, right? So this becomes 100 minus 100 plus 12, right? So you can clearly see that this particular value can be expanded into this. Why am I writing it like this? It's just a normal way of representing any decimal number. So for example, if I have 1, 2, 3, 4, I can expand it as 1 into 1000 plus 2 into 100 plus 3 into 10 plus 4, right? So you can clearly see I can write this value like this. So what I just basically did was I tried to focus on this particular minus 1 and realize that this minus sign belongs only to this leftmost digits and not to any other digits. So I can try to expand this particular value as minus 1 into 100, then 1 into 10 plus 2. So it is basically 100 minus 12, or I can also write it as, if I want the absolute value, 100 minus 12 like this, right? So this is minus 100 plus 12. If I subtract this whole value by minus 1 to make it positive, this becomes 100 minus 12. So when you reduce the original number into this particular state, the second number will always be smaller than the first number. This is guaranteed. So 100 minus 12, you can easily calculate it to be 88, right? Which was the required answer. So let me just take one more example. So here we have 710 and 63. So 710, 63, and the answer is coming out to be 647. So let us try to solve this particular problem. So we have 063, then we have 710, and then we have the final answer, right? So we are going to subtract the bigger number from the smaller number. 3 minus 0 is 3, 6 minus 5 is 6 minus 1 is 5, and 0 minus 7 is minus 7. Since we have no way to borrow, it is going to be written by as minus 7 only. So what we do, we expand it, minus 7 into 100 plus 5 into 10 plus 3, right? This is our whole value. So how can we write this? We can write it as minus 7 into 100 plus 53, right? Or this value is negative, I want the answer to be in positive, so I can also write it as 700 minus 53. So it is equivalent to 647, right? So you can clearly see whenever the first number is smaller than the second number, what we are going to do is we are going to compute the operations normally. The only thing is, if the most significant bit needs a carry, what we are going to do is we are going to write it as it is minus 7, right? And we are going to expand it as minus 7 and that number of zeros that are after it. So in this case there were two zeros, so we have two zeros here, minus 700, right? Since we want the number in positive, what we are going to do is we are going to make this number positive and all the remaining values that we have, we are going to subtract from it, right? So this is just twisting your original values into such a way so that you can fit it into this particular manner. So I tried to explain you the mathematical reasoning behind doing all of this stuff. Now it's up to you how you try to implement it. You just need to know that whenever your most significant bit produces or needs a carry or a borrow, what you're going to do, you're going to write that particular digit, append needed number of zeros after it, and then subtract the remaining value from it, right? And that is going to give your final answer, right? Now, this was the case that I wanted to discuss. But in the normal case as well, you can just simply borrow and do everything. So if you write 710 and then 63, what you're going to do, this is going to borrow. So this becomes 10 and we have 7 here. This becomes 0. So it needs to borrow. It borrows 1 from here. So this becomes 10. 10, 1 was given here and 6 is given here. So this becomes 4 and then we have 1 is subtracted from here. So this is 6. Right. So this is how you can solve this particular problem. Now 647 is the final answer, but now again the question is, I can explain you this particular part this way, but how do we actually implement it in a linked list? So as we can clearly see in all the operations, we are moving from right to left. Right, this is our very first observations. No matter which case we are dealing, we are always moving from right to left. And also the rightmost digits of both the numbers are connected. That means the first digit from the right must be treated together for both of the digits, both of the numbers, and the second digit from the right must be treated together for both of the numbers, and so on. Right. So in order to make our thing more easier, what we are going to do is we are going to reverse the original numbers first and then go from left to right in those linked lists. Right, because it is easier to go from left to right and not from right to left in a single linked list. So that is why we are just going to reverse both of the linked lists to make our calculations or make our work a little bit easier. Right. So let me copy the code for this subtraction and then make you understand what we are trying to do. So I'm just going to take this. So we have the code here. Yes, moves. So this is the code that I have implemented for the subtraction part. Let us see what we are trying to do here. So first of all, I'm going to receive the head of the first linked list and the head of the second linked list. Now this head is the reverse number. This is not the actual number. This is the reverse number. I have already reversed both of them. Now I create this linked list answer and second. So you'll see in a while why they are important. But let me first show you that they have already implemented a linked list class. So this makes our work a little bit easier. To insert a new node into the linked list, what we can just do is we can call this insert function. Right. So let me show you here what I've done. I've created this linked list of answer and second. So when we do this, they automatically create this head and tail associated with that particular linked list, and we will call this insert function to insert a new node into that linked list. So when I create this answer and second, answer is going to store my final answer of the subtraction, and second is going to be a special linked list. Why special? Let me just tell you this. So you clearly saw that whenever we encounter a case like this, right, I need the last value 7 and then certain zeros after it, right? So instead of computing this particular thing when I reach the end, I am also maintaining this particular number together only, right? So this is what I am trying to do. Now this computed number 700 will be stored in this particular second linked list, and my final answer will be stored in this answer linked list. So initially the carry is 0, while head 1 or head 2, that basically means if either head 1 is not null pointer or head 2 is not null pointer, that when I am going to enter this particular value, when both of them becomes null, I am going to exit. Right. Now what I do, current is equals to head 1 minus head 2 minus carry. So why this complex sequence of letters? You see that I only can calculate the value of head 1 if it is not null pointer. This particular while loop will get entered even either of them is not null pointer. So that basically means it can be very well possible that one of them is null and the other one is not null pointer. This is an actual node, right? So I have to carefully check whether this particular head is null or not, right? So if it is not null, I am going to use its data, otherwise I am going to use 0. If head 2 is not null, I am going to use its data, otherwise I am going to use 0 and then subtract carry from it. Now the next carry will be equals to current minus 0, current less than 0. So that basically means if my current becomes less than 0, it needs a carry and then carry will be 1. Otherwise, if current is greater than or equals to 0, that means I don't need a carry and then carry will be equals to 0. Now if carry, that means if carry is needed or I need to borrow from the next number, what I'm going to do is I'm going to check whether the head 1 has a next node or the head 2 has a next node. Right. So for checking the next node, I also have to check whether the current node is itself null pointer or not. Because if the current node is null pointer, then the next will never exist. Right. So I have to first check whether the current is null pointer or not? If it is not null pointer, I have to check whether the next is null pointer or not. So basically here I am trying to check whether either of them has a next node or not. Why this condition is important? If you see at this particular position, both of them do not have any next position, right? Both of them gets finished here. So this is the condition I am checking, that I need a carry but there are no next numbers, right? This is the condition that I am checking here, that I need a carry. This comes from this particular if, and there is a next node with either of the heads, right? So that means there is a next node for either head 1 or head 2, right? So if there is a head for either of them, what I'm going to do is I'm going to insert 10 plus current in the answer vector and 0 in the second vector, second linked list and the answer linked list respectively, right? So what is this going on? So basically my current is negative, right? And if either of them has a next node, that means I can try to borrow something. So that when I borrow 10, I'm going to borrow 10 and then I'm going to subtract current from it. Since current is already negative, I'm just going to write 10 plus current. So you can clearly see, let me just try to give you an example. So let's say it was 0 and 3, right, like this. So 0 minus 3 is minus 3. When I borrow 10 from here, it is going to be 10 minus 3, right? So this is 7 eventually, right? So this is what I'm trying to do here in answer. And for second, I just insert a simple 0. So why is this 0? Because I want 7 0 0 and these are the zeros that are getting inserted right now. Now if we need a carry and we are at the last position, for example in this particular position we need a carry and we are at the last position, there are no further nodes, I'm going to reach this particular else part, and here I'm going to insert absolute of current in the second linked list. Why second linked list? So you can clearly see my second linked list, if I go to this particular case, it is going to be 0 0 and then I have minus 7. So I want only 7, so that is why I'm going to use 7. I'm going to show you a dry run of this particular code when I finish explaining, so you don't need to worry about it, right? So I'll have 700 in the second linked list at the end. So it is not going to be 700, since everything is reversed, it is actually going to be 007 like this. Now what I do, if I don't need a carry, I can just insert my current value, which is always going to be positive or 0 in my answer linked list, and insert a 0 in the second linked list. Now if head 1, that means I have a head 1 and it is not equal to null pointer, I am going to move it forward. If head 2 is not equal to null pointer, I am going to move it forward. After I do this, what I am going to do here is, if carry, that means I still needed a carry and both of the numbers are finished. This corresponds to the condition where the first number was less than or equal to the second number, So basically what I am trying to say is, if the first number is greater than or equal to a second number, when you finish subtracting both of the numbers, there will never be a carry, right? If there is a carry, that means the first number was less than the second number, right? So I am going to return these two numbers. What are these two numbers? Second head and answer head. So second and answer, let me just discuss what are these values. So after all of this has been done, in this particular case, when we have 0 6 3 and then we have 7 1 0, my second value will be equal to 700 and my answer value is going to be 53. Now what I need to do is, I need to do 700 minus 53 to get my final answer. So that is exactly what I do here. I am going to return these two values, and if I receive these two values, I am going to perform an operation on these two values again. The same subtraction operation perform again. So now let me just give you a dry run so that it is much easier for you to understand this particular part. Otherwise, you might get confused from here. So let me just take these two numbers. The first number is 63 and the second number is 710, right? So if I write 63 in reverse order, it is going to be 36 and 710 is 017, right? So I can append a 0 after it to make them both equal number of digits. So now what I do, I move from left to right. I check my head 1 is not null pointer, so I am going to take 3. My head 2 is not null pointer, I am going to take 0, and initially the carry is 0 only, so I don't have to subtract anything. Now my current value will be equals to 3, right? My current value is 3 and carry is 0. So I come to this particular part and I insert 3 in my answer. So answer is 3 now, and my second is 0 now, right? So now I move on to the next digit. So please remove this. Now the value is 6 and 1. So my head 1 has value 6, my head 2 has value 1 and my carry is 0. So now I will get 5. since current is greater than 0, carry is going to be 0 as well. So now I append 5 and 0 here, coming to this particular condition, right? Because I don't have a carry currently. Now what I do, I'm just going to remove all of this again. Now I come to the next digit. Now what I see, I have 0 and 7. So my head 1 is 0, my head 2 is 7, and my carry is 0. So 0 minus 7 is going to be minus 7. Since my current is less than 0 now, my carry is going to be 1. So I enter this particular part. Now I check whether head 1 and head 1 dot next. So head 1 is going to be true because it is not null pointer currently, but the next node is null pointer, so this condition is going to be false, right? So the whole this particular part became false. Similarly, this particular part will also become false because there is no head 2 next. So basically that means we are going to enter this particular part, right? So what is the value of current? Minus 7. What is going to be its absolute value? 7. So we only insert a 7 here, right? So now we have the numbers 35 and 007. So these are both in reverse order. So basically we have 700 and minus 53. This is what we want to calculate now. So what I'm going to do here is I'm going to return these two values. I currently have 35 and 007, right? So I'm going to get head 1 as res dot first and head 2 as res dot second. What is res first? The second value, and what is second? Head 2 are the answer value. So basically this is going to be my new head 1. Head 1 becomes equals to 007. This is the first linked list, and head 2 becomes equals to 35. This is the second linked list. Now I am again going to perform the subtraction operation on head 1 and head 2. So basically the same subtraction operation, it's just that the numbers are now changed. So the function is still the same. I'm just going to remove all of this. So let me just quickly remove this. So in this particular case, I will have 007 now, and then I'll have 35. So I come here at this particular position. My head 1 is 0, my head 2 is 3, and my carry is 0, right? So I'll get minus 3 from here. Now my carry will become 1, so I get to this particular part. Now either head 1 has a next or head 2 has a next. In this particular case, both of them has a next value, so I'm going to enter this particular part. Now my answer in this particular case, let me just remove some of it. I'm just going to remove this. My answer is going to be 10 plus current. My current value is minus 3, so 10 plus 10 minus 3 is going to be 7, and my second value I am going to insert a 0, right? Now I move forward, I move here. My initial value is head 1 value is 0, my head 2 value is 5, so I remove this and I write 5 here, and my carry value is 1 now because I produced a carry here, right? So my next carry is going to be current is less than 0. So the current value of current is 0 minus 5 minus 1, so it is minus 6, right? So I enter this particular part. Now again I see whether either of them has a next value. So we can see head 1 has a next value, but head 2 doesn't. So if head 1 has a next value, we are going to enter this particular part. We are going to add answer dot insert 10 plus current. Current value is 6, so I'm going to write 4, right? 10 plus 10 minus 6 basically. And in the second factor, second linked list, we are just going to insert 0, right? Now I move on to the next position. So let me just erase this. I'm just going to remove all of this. I move on to the next position where I encounter this particular value. The first value is 7, so it is 7 here. The second value is 0 because there is no node, and the carry value is 1, right? So 7 minus 0 minus 1 is going to be 6. The value of current is 6 now, and if carry equals to current is less than 0. So in this particular case, since current is greater than equals to 0, my carry is going to be false, so I enter this particular part. Now what I'm going to do, I'm going to insert 6 into my current, which is the value of current. I'm going to insert it into an answer vector, and for the second I'm just going to insert 0. So since in this particular case the first value was bigger than the second value, the value that what we have in the second linked list doesn't really matter. It is only useful when the first value is less than the second value. So we have got 746, right? So at the end what I do here is, if carry, I'm going to return both of them, otherwise I'm just going to return answer dot head and a null pointer, right? So this is also very important here. Why? Because when the second value is null pointer, I am trying to indicate with the help of this null pointer that my first value, it indicates, let me cite it, null pointer indicates that first value was greater than or equal to the second value, right? So here I check if res dot second, that means if it is not equal to null pointer, I have to perform a subtraction operation again. Otherwise, I just set my final answer as res.first, right? So you can clearly see that we are using this particular null pointer as an indication. So our case was this one in this particular thing, when during the first subtraction our res.second was true. So we perform the second operation and set our final answer as the result of that particular second operation. So after the second operation, this condition is going to get triggered because here our carry value is 0 at the end, right? So I'm just going to take this answer.head. So what is answer currently? It is 746, right? Now what I do with the answer, I just reverse the answer, and while final answer data is equal to 0 and final answer has a next value. So why is this condition important? Because it is very well possible that I get several zeros after it. So when I reverse it, it is going to be 000647. Now I don't need the beginning zeros. So what I do, I just remove all of them, right, and just return 647. Now there is again a possibility when all of them are 0. So if all of them are 0, all of the zeros will be removed, right? I don't want that. I need at least one 0 to be remaining. So that is why I use two conditions here. While final answer data is equal to 0 and final answer has a next value, that means this is not the last node of the linked list. Only then I'm just going to move on to the next value, and then I just return this final answer, right? So I know this video is very long, and I have tried to explain the solution by doing dry run of certain cases to help you understand what I was trying to do, right? So let me quickly go through the whole problem again, what we are trying to do. So first of all, we just assume that the first number head 1 is going to be greater than or equal to the second number head 2, right? So what we do basically is we reverse both of the numbers and just call the subtract function. Now we do the subtraction here, right? And if the last digit produces a carry, that basically means the first number was less than the second number, and hence we need a second subtraction. I have already told you why and how to do it, right? So I pass the respective values here. Otherwise, if the first number was greater than or equal to the second number, then I only pass one value and a null pointer, right? When I receive the answer here, I check whether the second number was a null pointer or not. If it was not null pointer, I am going to perform a second operation or a second subtraction. Otherwise, I am going to set my final answer as the current value that I got, right? During the second operation, I update my head 1 and head 2 and then again call the subtract function on head 1 and head 2. I have already explained why we do this, how we do this, and when this particular second operation happens, it is for sure guaranteed that this particular condition will not get triggered again like the first time. When we perform the second operation, our first number is guaranteed to be greater than or equal to the second number. So this condition will get triggered, right? When we get the answer from here, I set my first final answer as this one. Now, since I have to reverse the final answer, I reverse it. I remove any leading zeros from it, and then I reverse and then I return the final answer. So this was all about this particular problem. And let me quickly submit this to show you that this particular code works and the solution is absolutely correct. So you see, this passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.